Hello and good day. My name is Alvin R. Palma Jr. and today I'm going to be discussing my project in Robotics 1. So the project is all about giving blind people vision for our thesis. So this is like a prototype. So yan, future prototype for thesis project for detecting obstacle for the visually impaired. So this is the code. So the flow of my project would be that an ultrasonic sensor will uh, detect an object and get the distance, and the distance will control the uh, motor speed. So if the distance is close to the user, the speed of the motor will increase, and if the distance of an object is far away from the user, the motor speed will decrease. And it is selected by having an analog input. And if it is set from 0 to 2.5 volts, it will select the ultrasonic sensor. And if it's the analog input is greater than 2.5 to 5 volts, the input will be the PIR sensor, and it is to detect motion that will prompt the motor to buzz and LEDs to blink if motion is detected. So for recap, 0 to 2.5 volts, uh, the device will be set to ultrasonic, and if it's uh, set to 2.5 to 5 volts, the device will be set to detect motion. So here's the code. So first we define echo pin. Echo pin is for the ultrasonic. It is where the ultrasonic will detect the pulses that is triggered by the pin, trigger pin 12. So since this is a Simulink, there is no ultrasonic sensor here. So the only necessary pin is echo pin 2, which is the input. And it is done with this pulsar over here in the so long duration, it's just a variable. So initiate distance, it's another variable for distance measurement. And next is the initiate sensor, which is located in pin 1. This is the PIR sensor. And we have the initial state. This is a that is a junk code. And next is for the val 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 equals 0. This is important for the uh, variable for the PIR sensor. And we have initialize ing. This is important for the analog input. So here we have the void setup. So for pin A0, it's the analog input. For the 4, it's the output for LED. Pin 3 is output for motor, which is for PW, with which has a PWM capacity. So next is pin mode trigger pin output. So ayan, it's in pin 12, and pin mode echo pin input, which is in pin 2. And for the sensor, it's an input in pin 1. Okay, so for the first logic, so we first read the data from the analog input, and if I is less than the half of the analog input, which is at value of 1023, so divided by 2 lang siya, the the device will be in distance mode, and the Logic for that is that the duration is equals to pulse in echo pin high. So pulse in is just, this is basically just for detecting the pulse that is emitted by the trigger pin that is bounced back to the echo pin. So that's the duration. So the duration in, I guess this is seconds or milliseconds. The duration is times by 0.034, which is the speed of sound, and divided by 2 since it the duration is going forwards and coming back. So that's the distance of the object. And we have here is a logic. So J is equals to 255 minus distance over 2. So here, analog right, 3J. So what this means is that if uh, the distance of an object is far, the the subtractor would be larger. So the speed of the motor would be slower. Yon. But yun lang. That's for the ultrasonic logic. And next is the here. If I is greater than half of the analog input, it goes to motion detection. Motion detect. So if the motion detect is enabled, both the motor and the LED will blink. So 3 and 4 will blink. So first we need to initialize it into low, and if value is equals to data read sensor, so if the PIR sensor has sensed something, it will be equal to val, and if val is high, we do a for loop, which is simply a blink function. So for initialize x is equals to 0, x less than 2, and then x plus plus. So it will loop once. So blink, 3 and 4 is high, delay 0.5, and then low, and then delay. But if the sensor has not detected motion, it will turn off. It will not blink. So let us compile, accept, and this for pin number 1, which is the push, it is a uh, it is a PIR, so it will basically just detect. So if it's high, it detects motion, and if it's low, it does not detect motion. So let us set it to no. And for A0 is the analog input, and pulsar is the ultrasonic sensor. So it's in pulse. So let us test it. So we run. So here I have set up the ultrasonic sensor to be very let's just simulate that the object distance is very far, which is in 425 centimeters. This is in centimeters, so it's roughly 4.2 meters away. So the motor is not running that fast. But if we shorten the distance or shorten the pulse to say 15,000, you can see the motor increase its speed because the distance now is at 2.5 meters and the speed is now at 128. And if we have that, so 10,000, the distance is now at 1.7 meters and it's running much faster. And how about we set it to 5,000? And the distance of the object is less than 1 meter and it is yan, it's 213. Oh, sorry. 213. The speed is going very fast. And if we have it, let's say 1000, the distance is at 17 centimeters. It's almost at max. And say we go 500, we go 50. The distance is 0 and it is going at max speed. So that is for the ultrasonic sensor. So its functionalities for the blind. Imagine the motor as a haptic motor that vibrates faster to warn the user. So we go on to the PIR, motion sensor. And as you can see, there is no motion detected. So because the sensor is detecting no signal, but for example, we detect a signal, it will buzz, buzz, buzz. Yeah. So the motor is used to warn the user that there is motion ahead, and the LED is used to warn other people that this guy is blind and it should be a caution. So as you can see, it's blinking like a caution signal in cars blinking. So the other people should be cautious around the blind person. So mm, I decided not to like create a 7 segment uh, input or output because this is for the blind and it's very over. It's like putting a pedal in a wheelchair if we give a 7 segment display, and that is all. That is all for my project. My name is Alwin R. Palma Jr. Thank you and goodbye.